Okay, so I wanted to kind of compare the two different strategies. The one that we started to do in the lesson, at the end of the lesson, and then also the one on the right is the one I emailed you here. This is the strategy that I taught to my pre-calculus students over the summer, and it works really well, but you have to make sure that if you use one strategy or the other, you make sure that you keep things straight, because this little number here, this C, this little constant that we're trying to find, it's different when you do each different strategy. It's going to carry a different sign depending on what we're looking for. And that all boils down to, if you're looking for the zero or if you're looking for the actual factor, the entire factor. So it can get confusing, but what we started to do in our lesson, we just started, finding our P's, finding our Q, and then making our P over Q's. And these are all our possible real zeros. So, and I had a chance to review that after we hung up, and it all came back to me. So what I wanted to point out then was, because, I used this strategy. So a lot of times when you mix and match strategies, you do get confused. But you are going to be expected to know when to use what strategy depending on the problem. So the way that we started out, so we had our P and our Q, and you used your synthetic division. You picked out a couple that you thought might be correct. And I went ahead and I did the synthetic division for your sake here on the 3 and on the negative 1/2, since we already knew that they were zeros. Now keep in mind again, when you're doing synthetic division, the number that's outside here is the actual zero. Because if you look at our graph, 3 was a 0. Hold on. And then when you take that 0 and you put it in to one of these factors, it becomes x minus 3, like this one here becomes x minus 3, because this is the 0. These are zeros out here. And so what makes this factor, this entire factor, 0? Well, 3. So 3 is the 0. So that's when you do synthetic division. Now, mind you, the analogous process to doing this is actually doing x minus 3 the long way and dividing it into, 2x cubed, minus 11x, ... And this is where I made my mistake. It's plus 12x, and I copied it wrong. I put minus 12x plus 9. So when you do long division, you're actually dividing the factor, the actual factor, into here. And then so if you get a 0 down here as your answer, then this is your factor, and it goes up there. That's why it's a little more straightforward when you're just, looking for factors, but it takes longer. If you notice, you were already done, and I'm just sitting here plugging away at the long division. So people do use this method because it's quicker and it finds you your 0 right away. So just remember that. When you put it in here, that's your 0. 3 is the 0, so the factor is x minus 3. Okay, so that's great. So now we still have to keep in mind, though, that these 3 numbers still have to add up to 9, or not add up, multiply. They have to be multiplied together, and their answer when you multiply them is 9. So you just happened to find that negative 1/2 was another 0, I think because you looked at the graph and saw that negative 1/2 was one of the other zeros. So rather than go through everything, and that should kind of make sense because it's got to be a fraction after I thought about it, because we have this 2 here, and it's the 2 is going to make it, when you multiply these together, it's going to kind of mess things up a little bit. Well, not necessarily. Let me backtrack. Not necessarily at this point, but at any rate, I won't jump ahead. So you have your negative 1/2. We did synthetic division with that, and we came out with 0. So now, since these are your zeros, then you know that they're going to go in these two factors. You know that they're not going to go in this slot here. And the reason why is because this is x minus, and I'm going to just put, because it's always minus the 0. If you can see the standard formula here, you're always minusing the 0. So x minus, because in that manner then I can say that that's my 0. So it's really x plus 1/2 when we distribute the negative signs. And the 0 is negative 1/2. So negative 1/2, let's get rid of that better. Negative 1/2, and this is plus 1/2 will give us 0, and that'll make, 0 times anything is 0, so our y will be 0. It's not going to go in here because if we're saying it's a 0, then it's the value that's going to make this whole function 0. For this constant here, this c value, it's kind of c1, the way that I got it was, since we know that the negative 3 times, and let's just make this positive 1/2 now because we're going to get confused. Oops. Let's change that to okay, just so it looks neater. So this was negative 1/2 was the 0, so positive 1/2. So we know that a negative 3 times 1/2 times this factor here is going to give us 9. And I did the same thing over here, only I'll have to show you that in a minute. But over here, if I were to solve for this other constant here, I would say, okay, and we're going to just call it, we'll just call it C, because I don't want to call it C sub 1 like I did here, because C sub 1 is a different number here because I already factored the 2 out. In the standard form, you always factor out your leading coefficient, whether it's this or anything else. So I'm just going to call that C for right now. So it would be then C times 1/2 times negative 3 is going to give us 9. This 9 right here. So then, just like I was doing before, then C times negative 3/2 equals 9. So then C equals 9 times negative 2/3. And so C, now C, mind you, not X, but C is 9 times negative 2, which is negative 18, divided by 3, and that's 6, negative 6. So that's the value of C. That's not looking at this formula, but just looking over here at these factors. So C is a negative 6. And so if we were to just go ahead then and put that in there, it's a negative 6, we could even see that these three factors are going to give us a 9. Mind you, this is C. This isn't the 0 or the number that's associated with the 0, because we have to set this whole thing equal to 0 to find out what the 0 is. The 0 is 2x equals 6, so x equals 3. So that's our 0, which was just like this 0. This 0 had an x equal to 3. So this one is also has a 0 of x equal to 3. But the C that we solved for here was negative 6. And when you multiply negative 6 by 1/2, you get negative 3, and negative 3 times a negative 3 gives us that 9 that we were talking about. So this is a little bit different method than this one over here with the formula, because over on this method we factored out a 2. So, I mean, we didn't factor out a 2, whereas in this method we did factor out the 2 because we wanted this pure form of a polynomial. And this is the standard form for a third degree polynomial, but it's the same thing for any degree. You just keep going on and on and on, and you have this a outside here. Okay, you're not quite sure what it is, but you can always solve for it. And the only reason I knew that I could just factor the 2 out is because I could see that the leading exponent here, it could only be a 2, and 2 times 1 are the only two factors that I could have for this leading exponent. So it's so obvious that, one of them is going to be a 2, and then the other two are just going to be 1 for the exponent. There's nothing else we can put there. So in that case, these two factors were just 1x. So these two factors, whenever we found our true zeros here, we knew that they went into these two factors. Because if these are our true zeros, they're not going to go here, because it wouldn't be a true 0. If I were to put the 3 here, that wouldn't be a true 0. The true 0 for this factor is when you take this and set it equal to 0 and find out what x is, when, the value of x that makes this 0. 2 times 3 is 6. 6 minus 6 is 0. 3 is the 0. 6 is just the C that we found down here by doing that little strategy with the 9. So these two methods are different. I do really like this method where you just have the a outside, and it starts to become rather fun and like a game, because there's problems where they'll give you the zeros. They'll say, okay, here's a problem, and the zeros are, and I'll just use these zeros. The zeros are 1/2, whoops, oh, maybe I can't write on there. Oh, for some reason. The zeros are 1/2 and, oh, no, that would be -1/2. -1/2 and 3. And the 3 0 has a multiplicity of 2. And that's what happened here, because we got a 3 again. So we call that a multiplicity. The 0 is 3, but it occurs twice when we go to factor. You don't see it twice on the graph. You only see it once on the graph, because of course you can't have this on top of itself, a 3 and then a 3. It doesn't show up like that. And that was the other thing that I wrote, and I think I wrote it down here, that, you know, right away you and, or me especially, when I looked at this, I was like, oh, there's only 2 zeros here and 2 zeros showing that are real, so the other one must be imaginary. Well, I had forgotten about multiplicity. So not only imaginary is not the only reason why you're missing a real 0. It also could have a multiplicity. One of these zeros could have a multiplicity. So these are the two instances, and in our instance, that was the reason. We had a multiplicity of 2 on this 3. So, but anyways, a lot of times they'll give you a problem and they'll say, okay, you have a negative, or you have zeros of, your zeros are -1/2 and 3, and the 3 has a multiplicity of 2. What is the polynomial? And then they tell you, and I'll give you a hint, f of 2 equals 5. In other words, when x is 2, the y value is 5. Well, this right here is how you find your a. So that's a fun little problem that I did with my students, and I don't know if I gave it to them as extra credit or not, but you'll see a lot of that in college, a lot of these kind of problems. So, so anyways, what you do is you have your zeros here. You just use this standard form with the x minus your 0, because see, now C1 is the 0 because we're using the formula minus. So if -1/2 is a 0 over here, we just put it in and use the formula. But then of course it turns out to be x plus 1/2, which is what it's supposed to be when we distribute the negative. So anyway, so you put your zeros in. You got a multiplicity of 3. So x minus 3. So then this one would be x minus 3. And you would have had all of your factors filled out, but you wouldn't have had a. Because in this particular problem, I wouldn't have given you a. You would have had to find out what this a was. So the way you do it is you set your factors. You say, okay, say this was just a, and I told you that f of 2 equals 5. That's your y value, is your 5. And this is your x value. So you come in here after you have everything set up. Your other one was 3. It was x minus 3. And I told you, your f of 2 is 5. That's how you find your a. So you put a 5 here for your y value, and for each of the x's you put in a 2. You put a 2 in there, you put a 2 in there. So you have this all filled out So now the only variable is a. So you work this all out, you solve it, you distribute, you multiply everything through, and you come to the bottom and you see what a equals. And a will equal 2 because we already know it's 2. So that's kind of a fun problem that they'll give you. You know, they'll talk about multiplicity and stuff, and they'll give you all these hints. So we'll do one of those, and maybe I'll attach the problem that I'm speaking of. And let me just get rid of these. Get rid of all of this too, because it might confuse you if you look at this again. Oh. Okay. So anyways, so those are the different strategies of finding the zeros. It's a little daunting if you switch from one to the other. So you might want to decide which one you like better. Sometimes this one may not work for you. Sometimes you might have to just use this one, use the formula. And then there's also, for the cubics, there's also the, I still forgot what that, I still forgot what it was. The a plus b, let me go find that for you and let me write it down at least. Okay, so I'll send you this handout so you have it, but you know how you have the difference of squares and whatnot, so you probably remember the difference of squares. There's probably not going to be enough room here to write it down, so I'll just send that one to you. Well, no, I should write it in, because then at least you'll be able to compare it. But the difference of squares says, let me use a different color. It says if you have a squared minus b squared, okay, that's the difference of squares. This is a square, this is a square, a squared. So the difference of squares is, and this one, you have a plus and you have a minus, is a plus b and a minus b. So if you ever see those, your middle, there's no middle term. The middle term drops out because you got a plus and a minus. You got positive a times b. You got a positive ab and a negative ab. That's why the middle term drops out. But with the difference of cubes now, there's a formula for it. So if you see something, and a lot of times they throw these in here along with these, with all the middle terms, they'll throw in one like this, and you'll be like, what the heck is that? And you'll have forgotten it, like I always do. Everybody forgets this. So then the difference of cubes has a special formula to factor it. It's just a minus b, so it looks just like this, and then it's the rest of the terms are all added, times a squared plus ab plus b squared. So both of these terms have to be perfect cubes, like 2 cubed. So if you see the number 8, and then this would be like 27. 27 is 3 cubed. Okay, so if you saw 27, 27 is 3 cubed. Well, that's the difference of cubes. This is your A, 2 is your A, this is your B, and you could just fill out this formula. So it would be 2 minus 3, 2 minus B. Let me move this up here. So it'd be 2 minus 3 times 2 squared plus 2 times 3 which is 6, plus 3 squared, which is 9. And you could simplify that. But that's what it would factor to. So you wouldn't, if you ever saw anything like that, like the difference of cubes or the difference of squares, you don't have to waste time going through all this, just if you can remember this formula. And then on the flip side of the difference of cubes, they have the sum of cubes has almost the exact same formula. So that one, well, let's see if I can write this better. That one is a cubed plus b cubed. Okay, so that's the sum of cubes. And then that equals, now this time it's a plus b. So this one started with a minus b. This one starts with a plus b. But then the rest of them aren't all subtraction like this one. The rest of them were all addition. No, of course, it has to be more difficult than that. The first one is subtraction, and that's it. So it's a squared minus, sorry about that, a squared minus ab plus b squared. So again, so if you have, any of these three, difference of squares, difference of cubes, sum of cubes, just try to remember this formula if you can. If you can't, then you're going to have to just, this is your P and this is your Q. So you could still go through this because you just don't have these middle terms. You got your P and your Q, your two N terms. So I hope that helps. I hope it didn't totally confuse you. Remember, don't make the mistake that I did. When you see this and you know there's 3 zeros and you think, oh, the other one must be imaginary. Well, when we went and did it, and I ended up with that -6, I was like, well, that's not imaginary. I completely forgot about the multiplicity, idea or concept or whatever. So, good luck. I will send you this video, and I will send you the factoring handout. And and I will send you that little game I told you that I played with, well, it wasn't a game, but it was a problem that I played with having them find the polynomial. So it's kind of going backwards. Now you're finding the zeros. Well, in this game they're giving you some of the zeros, and you have to find the polynomial. So, and you have to find A. Okay. Good luck. I will talk to you soon.